I would like to thank you, the organizing committee of this session, for giving me the opportunity to present Roman concrete in this prestigious context of ACI. Yes. With the help of a bibliometric research tool on sustainability of reinforced concrete interventions, life cycle is certainly the most discussed question about the topic of sustainability. And in case of monument, of course, the life is eternal, so is referred just to the interventions and is strictly related to monitoring and maintenance, as you can see in green. Limiting the research to the durability concept, which is crucial in sustainability, the remaining paper are just referred to infrastructures and bridges. So the need in the research community to develop subject about built heritage. Our proposal is an holistic approach which integrates different tools based on a common heritage building information modeling. The first problem in Roman concrete is the stratification of internation over time. Here, for example, in the famous sanctuary of Fortuna Primigenia, you can see the actual configuration given by the palace, Barberini Palace, over the original structures that you can see on the right in a plastic conserved inside the museum. So it's not always easy to reconstruct, model about all the steps over time. Inside the museum, we can see the benefit of integration between the photogrammetry, which is a virtual inspection, together with more traditional and non-destructive tests or semi-destructive. For example, the coupling with the double flat jack is really innovative, because in this case, the photogrammetry with the restitution of point cloud in step by step allows to catch the out-of-plane deformation of the masonry. Then we have tomography together with photogrammetry to have the texture combined with the section properties of the wall. And then finally, in the cryptoporticos, the photogrammetry combined with endoscopy can catch the interface condition between the old structures and the ground. Now, going clockwise in the city center, around the city center of Rome, we can start from Altems. Here we have an example of covering the original open court, and now the inspection revealed the really degraded concrete inside. This is an intervention of the starting of 19th century. Going to the Ludovisi cloister, which is a Michelangelo designed cloister inside the Crypta Balbi, we can see the great confidence in the new technologies typical of these years, with no design consciousness. You can see no framed structures, no continuity in column, no foundation. So it's not a good example. In the same bath, we have a complex system of covering of walls with intervention in reinforced concrete with in the same period of high confidence. And we can see in the content of frequency the heavy weight of the concrete, 5 tons of concrete, addition to the original covering. Again, the non-destructive test to point out a nonlinear model for the analysis, and then the traffic situation, which gives some peak velocity, even if in this case the subway doesn't seem to overpass the limit given by the codes. Differently, in Minerva Medica Templum, here we have a particular situation because the monument is between a tramway and the train rails, and then some monitoring of peak velocity reveals some measures close to the limit of the codes. This temple is particular because it has very difficult generation in intervention because of vulnerability at the starting of the construction. Here, recent monitoring system together with Enea, even if we use different instruments, different extraction methods for operational model analysis, we have results we are completely compared. And then also here we can see the amount of reinforced concrete, especially in foundation, and the complete reconstructions of the upper part of the monument to stop the degradation of the covering. It's blocked? Oh, no, okay. This is a sensitivity analysis to check the influence of the covering. Then, as last example of the integrated methodologies, the application of multi-criteria decision analysis for final evaluation of sustainability. The choice is from at least 3 reasons, and we combine different methodologies, starting from the more well-known analytical hierarchy process combined with a function value and with another methods to optimize the choice. This is the decision tree. The requirements satisfies the sustainability and are expressed by different criteria measured by indicators. Indicators are quite all measured by non-destructive tests or from literature correlations. And in these results, we compare different alternatives of intervention. It should be useful in the future to combine the research. We heard geopolymer concrete. We can try to use other mixing. This is the last example, the Crypta Balbi. In the model, you can have an idea of the amount of reinforced concrete in the Roman concrete monuments. You can see different kind of construction in the walls. This is the underground of this museum, and allow me a last consideration. Although these museums are open to a large amount of visitors from all corners of the world, so a conscious design of interventions would have great visibility in this kind of problems. And then some conclusions. 3 main distinguished periods characterize the reinforced concrete interventions: a transition phase, which was more moderate, and then how we have seen the confidence in new technologies, and now a compatible approaches in which we now consider the culture of design of intervention. Then we we have the last consideration. Now there are a research group who are studying in terms of sustainability, new mixing on the basis of Roman concrete, because it survived millennia, and which include long-term reactive calcium for long-term cracking filling. It is a study from MIT, and I think it should be it could be a good way for more sustainable intervention. Thank you.